In this example, we're going to do another integration by parts problem. So we're given a problem, we're asked to integrate, and we say, well, what strategy are we going to use? And we're going to learn a lot more strategies, but right now we really only have U substitution, look at the tables, which we haven't done extensively yet, and then also integration by parts. So one thing we know when to use integration by parts is when there's no obvious derivative of a piece in there. And so when I think about, what's the derivative of cosine? The derivative of cosine is negative sine, and what's the derivative of t cubed? That would be 3t squared. So I don't see the derivatives showing up, and that's kind of how I know that it's not U substitution. So I'll look at this, I think about Liate, if I want to use integration by parts. How am I going to choose my U? And since algebra comes before trig, I'm going to let t cubed be my U. So I'll say let U equal t cubed. And then we'll say v prime is cosine t. So U prime is 3t squared. And then the integral of cosine is the sine of t. So my next step for integration by parts, I'm going to write U times V, which is t cubed times the sine of t, minus the integral of v u prime, or 3t squared times the sine of t dt. So looking at this, we have to repeat that integration again. So I'll do my integration by parts again here. In this case, I'm going to say let U equal 3t squared, and then v prime will be sine of t. So the derivative of u prime, is 6t, and the integral of sine is negative cosine t. So this leaves me with t cubed sine of t minus uv, 3t squared times negative cosine t, minus the integral of v u prime. So v is negative cosine t, so I've got negative 6t cosine t dt. So cleaning this up, I've got t cubed sine of t plus 3t squared cosine t minus negative is plus, then we throw another negative in there. I've got minus the integral of 6t cosine t dt. So this step, again, we have to use integration by parts. And you'll notice, the first time I integrated, I went from cubed to squared. Now I've gone from squared to linear. So we should only have to do that one more time, because once I take the derivative of this linear algebraic expression, it's going to become constant. So I'm going to let U equal 6t. That means that U prime is 6, and my V prime is cosine t. The integral of cosine is sine of t. So, bringing down, I've got t cubed sine of t plus 3t squared cosine t minus, and my integration by parts is uv, so 6t sine t minus the integral of VU prime, so 6 sine t. I'm going to put that 6 in front. The integral of 6 sine of t dt. So I've got t cubed sine of t plus 3t squared cosine t minus 6t sine of t, and then minus a negative, that's going to be plus, and the integral of sine is negative cosine. So this last piece here, we've got negative cosine t, and I'll just rewrite that as negative 6 cosine t. And of course, because we are done, we write our arbitrary constant plus c at the end. So you should, see a pattern here. Went t cubed, 3t squared, negative 6t, negative 6, right? T cubed, 3t squared, 6t, 6. Those are all derivatives of each other. And then sine to cosine to negative sine to negative cosine. So that's like our circular differentiation situation, or integration, however you want to think about it. And there you have it. In this example, we did an integration by parts, where we had to use integration by parts 3 times in order to get our final answer. And you'll notice we started with t cubed. We had to do integration by parts 3 times.